We're going to talk about alkanes. Alkanes are a form of hydrocarbons, which means they have only hydrogen and carbon atoms. And alkanes are a form of hydrocarbons containing carbon-carbon single bonds. So when you say the spelling of alkanes, it's Alkanes. So the ending, which is A-N-E, if you see that in front of anything, it means it has a single bond. We're going to start by looking at some prefixes and the number, like I'll just show you here. So depending on the number of carbon atoms you have, there's a prefix that's assigned. So if you have one carbon atom, the prefix that goes with it is meth. If you have two carbon atoms, it is eth. If you have three carbon atoms, it's prop. If it's four, it's bute. 5 carbon atoms, pent. 6 is hex. 7 carbon atoms is hept. 8 carbon atoms is oct. 9 is non, and then 10 carbon atoms is dec. Let's look at an example. So say for example you have 4 carbon atoms here. So 1, 2, 3, and 4. As you know, the Lewis structure of carbon looks like this, which means it has 4 bonds. So 1, 2, 3, 4, which means every single carbon atom you see has to be bonded. So here you have 4 carbons. So let's draw the hydrogens that are associated with the carbons. And you'll see there's 1 here. There's 3 here actually, not 1. There's 2 here. There's 2 here, and then there's 3 here. So we haven't named the structure yet. First of all, this way of drawing, again, as you can see, because it's all single bonds, this is an alkane structure. This form of drawing is called structural formula. So this, you would call it structural diagram. And a structural diagram is when you have all the hydrogens shown. Now we're going to name this structure. We're going to name this alkane. It has 4 carbons. The prefix that could be bute, as you can see up there. So you're going to say bute. And because it's all single bonds, as you can see, we said the ending would become ane. So butane would be the name of this structure. So the ane means it's all single bonds, and the bute means that it has 4 carbon atoms, which makes it butane. This now butane can be depicted in 3 different ways. This is the first way that we have drawn, known as the structural diagram. There is another way of showing this, which would be the condensed structural formula, and that would be basically CH3, CH2, CH2, and CH3. So what we have done is, instead of these hydrogens being bonded here and we actually physically showing these hydrogens bonded, we've just condensed them sort of to say, okay, this is CH3, CH2, CH2, and CH3. The general formula for all alkanes when you name them is C, N, and H, 2N plus 2. Cn means the number of carbon atoms. This N is talking about number of carbons. And then the hydrogens are 2n plus 2, so 2 times the number of hydrogens you have plus 2. I'm going to look at some examples to sort of illustrate different ways of naming alkanes. So this is your first example. When we're naming alkanes, one of the key things you have to do is to look for the longest carbon atom chain. So as you can see in this, you have 6 carbons, and that is the longest chain. I'm going to sort of label this 6 carbon chain here. As you can see, this is a condensed structural diagram. The name is going to be hexane. So hex, and then ane because it's an alkane, and hex because there's 6 carbon atoms. Moving on to another example of naming alkanes. This is again an example of a condensed structural formula. Again, the first step always is to look for the longest chain of carbon atoms. Now you can do this in a couple of different ways in this example. You can go 1, 2, 3, 4, 5, 6, 7. Or you can also go 1, 2, 3, 4, 5, 6, 7. Okay, so this chain works. Or you can just go straight across, and that also adds up to 7 carbon atoms. That is the longest chain. I'm going to go across because it's easier to go across, and so again we're going to sort of show where our carbons are, and that's your. Now if you notice, you have these things that are separated from the structure itself are called branches. So this branch, because it is 1, 2, and 3, it's going to be called a propyl branch. Here you only have one other branch, and that is your methyl branch. You have two branches on the same carbon. The way it's going to work is you go alphabetically. So this is propyl and this is methyl. Methyl comes before propyl, so that's going to be named first. The way the name would look is it's going to be 1, 2, 3, 4. It's located on the fourth one. Again, as you can see, you can go either ways. It's going to add up. It's going to be on the fourth one. You can also go this way, and it's 1, 2, 3, 4. And that happens when you have odd number of carbons. The middle one, you go either ways. You can still adds up to the same one, the position. So if you go this way, it's 1, 2, 3, 4. That 4 tells us the location of the branches. So it's going to be 4. And because this methyl, we said methyl comes before propyl alphabetically, it's going to be 4-methyl. Again, there's a hyphen that is there between the 4. So it's going to be 4-methyl, hyphen between the name. And it's going to be 4-propyl. And then because it's a 7-carbon chain, the name becomes heptane. Again, the ane is because it's an alkane, hep is because it's 7 carbons. So the heptane part here is called your parent name. It's called the parent name. And the 4-methyl, 4-propyl are called your alkyl branches. KYL branches. Another way of naming is if you have a line diagram. Each dot or each point on the line represents a carbon. So there's 1 carbon here, 2, 3, 4, 5, and 6. You have a methyl branch on the 4th carbon and the 5th carbon. Now this is not the correct way of naming, because the rule is name from the side closest to the first branch, which means we have to go from right to left, not left to right, because the first branch is here. So the naming now is going to be 1, 2, 3, 4, 5, and 6. So now can you erase these numbers? I have 2 methyl branches, so it's going to be, name is going to be 2-methyl, again a hyphen, 3-methyl, and the total is 6, so it's going to be hexane. Because we have the same kind of branch, there's another way of naming this. This is actually the incorrect way. 2, 3, and then hyphen, and then you would say dimethyl hexane. Lastly, we've looked at examples that were in where we were given the structures. Now if they give us the name, if they say 3-methylhexane, we need to draw it out. Let's do it using the structural formula first. You have 1, 2, 3, 4, 5, and 6 carbons. You have a methyl branch on the 3rd carbon. So 1, 2, and 3. There is a methyl branch here, which means there's a carbon over here. Now because the way of drawing it is using the structural formula, it means we're going to bond all the other carbons to the hydrogen. You can have 3 hydrogens on this carbon here, the ends. So there's 1 here, there's 1 here, there's 1 here. You can have 2 here. You can have 2 here. You can have 1 here only. Now because don't forget this branch here, there's another carbon, which means this has to be bonded as well. So you can have 3 on this one. And then again, you can have 2 here. And 3 on the last one. If you look at the formula, CnH2n plus 2. So if you can always cross check. The number of carbons you had was 6. Or if you want to show it this way, it's going to be C6. It's not 6 carbons because we had a branch. We have to count it as 7. C7 and then H 2 times 7 plus 2. So C7H16. These are your examples of naming alkanes. And yeah, that's all. Thank you.